Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh, and hi everyone. In this video, we will discuss about chapter 2, differentiation. And we have two subtopics, which are chapter 2.1, derivative of a function, and chapter 2.2, techniques of differentiation. So, at the end of this subtopic, chapter 2.1, students should be able to relate the concept of derivative of a function to the gradient of a tangent, and as well as students should be able to find the derivative of a function using the first principles. Alright, so let's start off with the gradient of straight line is constant. Okay, so we have the gradient of the straight line is a constant passing through 2 points x1 y1 and x2 y2. All right, so we should write the gradient as m equal to y2 minus y1 over x2 minus x1, or it can be written as m equals to fx1 plus h minus fx1 over x1 plus h minus x1. All right, or it can be written as well as x1 plus h minus fx1 over h. So we should write m here. Okay, so the gradient of a straight line is constant passing through 2 points. And what about the gradient of a curve, for example? Okay, so the gradient of a curve is not a constant, okay, because it changes continuously from point to point. All right, so let us try to figure out what is the gradient of the chord AB. So this is your AB. Okay, so the gradient of this curve changes continuously from point to point. So from point A is different, up to this point it's also different, this one and this one. Okay, so let's say that we would like to find the gradient of the chord. I should write chord here. So chord AB. All right, so let us try to write MAB, for example. So it is the fx2, right? So minus with fx1 over x2 minus x1, or it can be written as fx1 plus h minus with fx1 over h. Okay, so if and only if the h is equals to x2 minus x1 and x2 equals to x1 plus h. All right, so suppose that when h is approaching to 0, okay, so this one that you need to relate with chapter 1 limits, okay, so then the chords of chords AB, so it will give better approximation. All right, so it will give a better approximation. So we should write here approximations for the gradient. Okay, so for the gradient of the tangent line at particular point A. Okay, and hence the gradient of the curve at A, so I would like to write here, so the gradient of the curve at point A is given by, okay, so let's make this a little bit smaller. Wait. So I'm going to move this one to this bit. Okay, all right, so it's given by the limit of fx plus h minus fx over h as the h is approaching to 0. Okay, so basically this is the introduction on how the formula of a first principle being derived. Okay, so we will talk about first principle more in our next video. So that's all for the time being. I'll see you again in our next video. Bye.